In a previous video, I shared a discovery I made regarding the Anker F3800's battery port, and it produced some really interesting discussion online in several different communities, and it was really interesting to read through all the different perspectives, lots of positivity and excitement, some negativity, but overall just a lot of confusion because it's unclear as to how this port is even live in the first place, and it's especially unclear as to what you can do with the port. So I've set up a range of different tests today to hopefully be able to answer as many of those questions and confusions as possible. Starting with the basics, such as, is there an output voltage? Yes. And what happens if you try to apply current into that voltage? In this case, I'll be using a charger. The slightly higher voltage than the battery is currently at. And as you can see, the charger is currently charging. And with a voltage source plugged in, whether that's a charger or a battery, here's how it looks on screen and in the app. As you can see, there's not really anything different, no indication, nothing. Now, before we can perform any serious testing, we need to address the connector. And in the previous video, I came up with this solution involving two female 4mm bullet connectors, and that worked pretty well, but it didn't offer the most secure fit, and obviously it's nothing like the original connector. So I wanted to take a shot at that, and with the help of Juan Carlos Medina on Facebook, who sent me a rough draft of this 3D model, I was able to improve upon it and come to something approximating a replication. My biggest disclaimer would be for the bullet connectors themselves. My order on AliExpress was taking so long that I went ahead and ordered some of these on Amazon. And both are supposed to be 5.5mm bullet connectors, but the dimensions and the design are completely different. There must be several manufacturers of these. And so these are shorter and fatter, and they have much more of a pronounced flange right here than the ones I ordered on AliExpress. And so my theory is that those will work better, and I'll try to implement those once I get them. Yeah, wouldn't that be nice? So I'm like an hour away from publishing this video, and I get a package. The connectors have arrived. Hooray! Finally, after weeks of waiting. But just one problem. It's the same bloody connector as the ones on Amazon. These are the Amazon ones. It's the same thing.
You just got pranked!
They're like ever so slightly different, like the hole down here on the AliExpress one is smaller, but functionally it's identical in terms of the actual dimensions. So yeah, I got AliExpressed. In the end, it's not that big of a deal because I made do with the Amazon type, or the only type, I guess, now, and it worked perfect, as you'll see. Didn't have any issues, but that is unfortunate that, yeah, I mean, I don't understand what there is to gain from lying about the appearance and specifications and dimensions and all that, but this is what I got. So yeah, Easter Bunny isn't real, Santa Claus doesn't exist, and AliExpress connectors are scams. But for now, these actually work totally fine. The only issue is that when you push them into the actual port, the contact that you make probably only gets to about right here. It doesn't go all the way in, thanks to this flange being so wide that it actually comes in contact with this plastic outer piece. And so I don't have any issues with this. I think that the fitment is so tight and good that there's not going to be any current handling issues, but just wanted to note that. The connector itself, the way you assemble it is to slide these pieces in, and they fit pretty darn tightly, so you might need to push them in with some sort of tool. But once they're in, then you grab this second piece, and the wire will obviously be soldered in at this point. This will fit around the wire, and you'll then be able to screw this into the frame itself with an M3 screw. And that will provide a secure connection that will not pop in or out, since there is a frame holding it in on this side, and then this piece right here holding it back on this side. So it'll stay firmly in place, and the result is something like this. The actual fitment is quite tight, so you really have to push. It gets to right here, and then the last couple of millimeters, you have to really push it into place. And I'm very confident about the connection. I don't foresee any issues for like 99% of cases as far as high current and thermals go. But it is important to note that this is a version 1, and it certainly can be improved upon. So keep that in mind. But for the time being, I'm going to post the STL files onto Thingiverse. And so any of you with a 3D printer can download them and print your own. And for those of you without a 3D printer, several of you have already expressed interest in something like this. I will look into putting these together myself and shipping them, or maybe there's a better solution that the community will come up with. I'm not really sure, but yeah, hopefully we'll figure something out with that. All right, starting with solar charging. And obviously the Anker already has solar charging built in, but that only gets you up to 60 volts, which is not enough for most people. So as you can see, I have a solar charge controller here. That's the box on the right. And that gets you up to about 150 volts open circuit on the input. So I'm powering that on. That's being fed from the Anker's battery port. And that's booting up now. It's just set to a standard 48 volt lithium iron phosphate battery charging voltage protocol. And so the way I'm going to be feeding power into it is not through a solar panel because it's like super cloudy outside, but through a very loud power supply. It's the reason I'm doing a voiceover. And then that's feeding this boost converter, which I just switched on. That'll boost the voltage up to about 75 volts-ish. So once I plug that in, the charge controller will see it as a solar panel. There you go, 73.9 volts. And it's going to be spooling up the MPPT, the maximum power point tracking, and tracking the maximum power point as I have set it according to the constant voltage, constant current. And you can see through that power meter there, we're getting about 400 watts, and that's going straight into the Anker's battery. And it's being charged as if it was a regular old 16S lithium iron phosphate battery, which it is. But yeah, there you go. High voltage solar charging on the Anker F3800. And I didn't even need to buy the Plus. But yeah, it just charges like a normal battery. It's super standard, nothing weird about it, no quirks. But that was only about 400 watts, and I wanted to try to hit the limit of this power supply, which is 1800 watts. But for that, I needed to supply 240 volts, which I had to do some weird wiring for. Had to be sure I did that properly. But once I made sure about that, I hooked that up, and you'll see here, it's just plugged straight into the battery. This power supply is a 60 volt, and I had set it to about 58.3 volts earlier. And you'll see once I flip this breaker on, about 32 amps passing through it. So 1750 watts. And I left this on for a few minutes. No weirdness, no issues, no overheating. And it seemed pretty happy about it. No issues. And the screen, the percentage went up by 1 when I took this picture, and it kept going up. As you can see, there's still no battery input indicator icon like you would see with the Anker batteries, and there's no input wattage indicator either. It's just the percentage. But it does still acknowledge that power is coming in and tally down to the percentage like normal. Alright, so in anticipation for the next test, I've gone ahead and drained the Anker down all the way to the point just before it shuts off. And that'll get the voltage as low as possible so I can get some really high currents. But before that, I just wanted to check what happens when you're only using this port and discharging from it. You get to right around 45.5-ish, where it would normally shut the system off. I wanted to see if it'll actually shut this port off. So I've wired up an inverter, and a fan to that inverter. Go ahead and turn that on. Running about 58 watts. And there's the voltage of the battery through that port. So let's see what happens. Let's see if it actually shuts off. There you have it. Shuts off at, what was that, 43 point something? So yeah, it definitely got a lot lower in voltage than the point where the inverter on the Anker shuts off. But it does shut off, so that definitely furthers my theory that this battery port is more akin to a direct connection to the battery, like you'd find on a 16S server rack battery, where the BMS will shut it off once one of the cells reaches 2.5, 2.7 volts, might be my guess, is that this is probably closer to 2.7, just because it didn't get all the way down to 40 volts, which would be 2.5 volts per cell, assuming that they're reasonably balanced. But yeah, it does shut off, so there is safety included, but let's see if we can turn it back on by plugging it in. The internal charger, that is. There you go. Turns right back on, and the port right back up to 43. There you go. Very cool. Alright, now for the fun one. As you can see, I've got this port hooked up to this battery here, and the only thing separating the battery in here from this battery is this breaker. And as you can see, the voltages are rather different because this one's at a high state of charge, this one's at a low state of charge. So the idea here is I want to see how much current we can push through this wire into this port, whether it will let us do that, and just what happens. I'm just curious what kind of current we'll be able to get, and also I wanted to see if my connector design holds up well. So I've got this multimeter set to measure temperature. It's currently at 75 degrees Fahrenheit, about 24 degrees Celsius, using Fahrenheit because it gives me a lot more granularity, but hopefully I can get everything in the frame. A lot going on. But yeah, should be interesting. 3, 2, 1. Oh yeah, hit 100 amps for a second. Seems totally fine. This breaker is 80 amps in case you were wondering. So it'll take up to 100, 120 amps for a few seconds to a few minutes. No problem. Now that they're equalizing, we're almost to 50 amps. And you can see the temperature's only risen by about 7-ish degrees, and this is right on the contact. It's actually touching the metal of one of the terminals. Oh, and the percentage has also risen to 3, so it is counting that for sure. Not even warm. Voltage is almost equalized. Alright, so now that we've established that you can indeed plug any old 48 volt battery into these ports, I figured I'd pull out the second F3800 and see what happens when you parallel the two battery ports directly. So, you know the drill. That breaker's the only thing separating these two batteries. So let's see what happens. Absolutely nothing. Which, to be honest, isn't that much of a surprise. They're both fully charged. And that was intentional. This heater is hooked up to this F3800's inverter. I'm going to turn that on. Should draw about 900 to 1000 watts. Now let's see if there's anything. Oh yeah. So all the output's coming from this F3800, but this F3800 is supplying current to this one's battery through these ports, equalizing. Just like you'd see on any standard 48 volt system with multiple batteries. Now, since they're both at 100%, and this one's only being discharged through the port, I figured it'd be interesting to see if the percentages go down at roughly the same rate. So some people seem to think that the units will not be able to measure the current near as accurately when there's power going through that port. That maybe isn't known about somehow by the system because there's not a signal being sent. And I'm not sure, so I'm curious to see. I just realized this could take a while at 1000 watts or a little less, so I'm adding a heat gun. That should give us about 1500 extra watts. Well, that was a dubious way to spend 7.5 kilowatt hours and 7.5 gigabytes. You know, I probably just could have taken a time lapse. Yeah. Anyway, that was really interesting. There was quite a discrepancy that formed there for a while. Actually had me kind of worried. It was above 20% between the two units for a while, but I was happy to see that towards the end, this unit actually started to power almost the full load as the voltage started to equalize at the bottom of the cycle. So, and I'm gonna have to review the footage, but it did appear that the percentage did follow the capacity throughput pretty closely, because you can see on here it cycles through, it shows the watt hours every once in a while. I was keeping an eye on it, and we ended up getting, I think, we'll see here in a second, yeah, almost the full 3800 watt hours, which is pretty impressive. But yeah, it looked like the battery percentage corresponded pretty well with the amount of watt hours displayed on there, but yeah, I'll have to check to make sure. But that's very good news if this percentage remains accurate even through this port, because, well, that just it expands the possibilities even further. You don't really have to worry about it being accurate, no matter how you're using the units, whether it's through the ports or not. So, but yeah, I could talk about that all day, but it's like 1:30, so I'm gonna go to bed. Yeah, night YouTube, and thanks for watching.